Find the critical path. In this problem, an activity table provides a list of activities, which includes a kickoff meeting, work performed by the general contractor, and 3 subcontractors, all followed by an inspection. The table also lists the duration of time it takes each activity to be completed. Although the units are not provided, this duration may refer to days, weeks, or even months. Predecessor activities are also included in the table. To find the critical path through the construction schedule, it is easiest to use a network diagram. To begin, we'll view an abbreviated version of the activity table and sketch out a simplified version of the network diagram, beginning with Activity A, because Activity A has no predecessor activities. Activity A is the predecessor of activities B, C, and D. So we'll add these 3 boxes to the diagram. Activity D is the sole predecessor of Activity E, and Activity F is a successor of activities B, C, and E. Next, we'll apply our template for the network diagram activity box to the simplified network diagram for all 6 activities. Using Activity A as an example, we would change the activity name to Meeting and add a subscript A to each of the 6 cells. After doing this procedure for the remaining 5 activity boxes in the diagram, we're ready to begin. In the network, the critical path occurs along the route for which there is no free float. The critical path may be through the general contractor, or through the first subcontractor, or through the second and third subcontractors, or perhaps there is not enough information provided. We'll begin by populating the duration of each activity using the values provided in the activity table. The durations of 0, 25, 16, 7, 12, and 1 are substituted in. We'll also assume the early start of activity A equals 1. This means the early finish of activity A also equals 1. Since activity A is the sole predecessor of activities B, C, and D, then the early start of these 3 activities equals 1, which is the early finish of activity A. Next, we can compute the early finish of these 3 activities by adding the early start to the duration, and the early finish of 26, 17, and 8 are computed. The earliest that subcontractor number 3 can start is the same as the earliest subcontractor number 2 can finish, which is 8. Therefore, the earliest that subcontractor number 3 can finish is 8 plus 12, which equals 20.